In this video, I'll be plotting the first order transient response of the circuit that I covered in my previous video. So if you haven't seen that, go watch it. From solving that problem, we know the time constant, the initial and final values of the current, and the final equation for the current. The first thing we're going to want to do is label our plot axes. So the horizontal axis is going to be time in units of seconds, and the vertical axis is the current through the inductor in units of amps. We know the value of the time constant is 0.6 seconds, so we can go ahead and put the multiples of the time constant on the horizontal axis. And we know the initial and final values for our current, so we can go ahead and scale the vertical axis. And we can mark our initial value for the current, 3.048. And we know that the current is going to asymptotically approach the final value. So we can draw an asymptote at 2.267, right about here. And we know that the tangent to the exponential at t equals 0 is going to intersect the horizontal asymptote for the final value at the first time constant. So we can draw the tangent. Then we want to have an idea of what points the curve is going to pass through. And we can approximate that at each time constant. So for the first time constant, we can do 1 minus 1 over e to the 1, which is approximately 0.63, which means that at the first time constant, the current is about 63% of the way from the initial value to the final value. At the second time constant, it's 1 minus 1 over e to the 2, which is approximately 86%. And then 1 minus 1 over e to the 3, which is approximately 95%. And we can mark those points on the plot approximately. So about 63%, maybe about here. 86%, about here. 95%. It's very close to the asymptote. And then we can smoothly trace our exponential curve as best as we can, making sure that we follow the tangent line at t equals 0. This is what our exponential curve looks like for the current through the inductor at time t.